Graphing an intercept form. This is our another video on how to graph quadratics given some other form. So y equals 3 times x minus 1 times x minus 4. We can tell the x-intercepts are going to be at 1 and 4, so that makes it easy there. Our y-intercept we can get after we substitute 0 in for x. So 3 times -1 times -4 gives me 12. So 0, 12 is my y-intercept. My point symmetric to the y-intercept we'll get after we get the vertex. I can write it in vertex form and standard form after I get that. So let's talk about how we can get the vertex. We can get the vertex in a couple different ways. We can distribute and then do negative b over 2a, but it's probably pretty easy to just figure out that if our x-intercepts are at 1 and 4, we can add and divide by 2, because due to the symmetry of parabolas, it has to be right in the middle. So my vertex must be at 5/2, comma, whatever happens when I plug in 5/2. So I get 3 times 1.5 times 1.5. Or times -1.5, sorry. So I get 3 times 3/2 times -3/2. If I do all of that, I get -27/4. So -27/4 is the y value of the vertex. -27/4 is like -6.75 if you want to think about where that is. Point symmetric to the y-intercept is going to be at 5 now. I know that because if my vertex is at 5/2 and my y-intercept is 5/2 to the left of my vertex, that means I can go another 5/2 to the right and figure out where that is. So I have a couple points. Oh yeah, my axis of symmetry is at x equals 2.5 or 5/2. So I can get that as well. So now I have a few points that I know are on the graph. I can get 5/2, which is 2.5, comma -6.75. That's somewhere down there. I know I have intercepts at 1 and 4. I know I have a y-intercept at 12 and a symmetric point at 5/12. And there's my graph. Now, again, this is one where I could make a table where I have 2.5 and -6.75 and go over 1 up 3, over 2 up 3 times 4, which is 12. But that just becomes a nightmare with all those fractions. So it's better if I get other points in order to be able to graph it. So to write this in vertex form, I get y equals +3 times x minus 5/2 minus 27/4. And then finally, to get it in standard form, I would distribute. So distribute like this. I get y equals 3 times x squared minus 5x plus 4. And then I distribute the 3 in, so I get y equals 3x squared minus 15x plus 12. And that squared looks a little bad, so I'll try that again. Okay, that's problem 1. Problem 2, y equals -x minus 2, x plus 4. So that means my intercepts are at 2 and -4. My y-intercept will be what happens when I substitute 0 in. So I get -2 times 4, which is -8, times that negative on the outside. So that's 0, 8. My point symmetric to the y-intercept will be, well, we'll figure that out when we get the vertex. So my vertex, once again, is going to be at 2 plus -4 over 2, so that's at -1. So my y value should be -1, or my x value should be -1, sorry. So I take that x value and I substitute it in. I get 3 times -3 times that -1 on the outside. So I get -1, 9 as my vertex value. The axis of symmetry is at x equals -1, and then I can figure some other stuff out. So my point symmetric to the y-axis or to the y-intercept is going to be at -2, 8, and then I could figure out other points by using my over 1, down 1, over 2, down 4, over 3, down 9. I could do that. Lots of different options in order to find my points. Writing it in vertex form, now that I have the vertex, is pretty easy. Y equals negative x plus 1 squared plus 9. Writing it in standard form is also pretty easy right now because distributive property works out pretty well. So I get y equals negative x squared plus 2x minus 8, which means I just distribute the negative at the end, and I get y equals negative x squared minus 2x plus 8. Finally, third question, y equals 1/2 x minus 5, x minus 5. So my intercepts are at 5, 0, and it's what we call a double root. So because it's a double root, that means that is also my vertex. Notice that I could rewrite this as 1/2 times x minus 5 squared. This is also technically in vertex form because I could have y equals 1/2 x minus 5 squared plus 0. Notice that the plus 0 could be there, so my vertex is also at 5, 0. So if I have only one x-intercept, that must also be my vertex. So 5, 0, axis of symmetry is at x equals 5. My y-intercept is going to be what happens when I substitute 0 in, so I get that at 25 halves, which is 12.5. The point symmetric to the y-intercept is going to be at x equals 10, y equals 25 halves. I already wrote it in vertex form, so y equals 1/2 times x minus 5 squared, and I'll move that down a little bit so you can see it. And then finally, writing it in standard form, I would distribute the x minus 5 squared. So I get 1/2 times x squared minus 10x plus 25. And then I distribute the 1/2 in, so I get y equals 1/2 x squared minus 5x plus 25 halves, or plus 12.5. So I get this double root here. It's over 1 up 1/2, over 2 up 2, over 3 up 4.5, over 4 up 8. And so that's that. Remember, it's going to cross the y-axis at 12.5. So that's our third problem, and that goes over vertex form.